Since the dawn of our species, we have looked up at the night sky, wondering what lies beyond. The moon, the wandering planets, and the distant stars have always sparked our curiosity. This urge to explore is woven into our DNA. Our ancestors mapped the constellations and dreamed of touching the heavens. The cosmos is the next great ocean, calling us to venture into the unknown. We explore not just because we can, but because we must. Each mission and discovery is a chapter in humanity's quest to understand the universe. We built rockets, sent probes, and left footprints on the moon. Every step forward connects us to our past and points toward our future. We build powerful telescopes to peer deeper into space and design advanced spacecraft to reach new worlds. The challenges are immense, but the pull of the cosmos is stronger. Space reminds us we are part of something much larger than ourselves. In exploring the universe, we become its way of knowing itself. This journey is both a responsibility and an adventure. We have only just begun to embrace it with the full force of our imagination, and so, we continue to look up, driven by wonder and the desire to know. When we think of space exploration, we picture astronauts, but our robotic pioneers are the true trailblazers. Probes, rovers, and satellites are our eyes and hands in the cosmos, enduring conditions no human could survive. Thousands of satellites orbit Earth, watching weather, enabling GPS, and connecting the world. These machines form the invisible infrastructure of modern life. Robotic telescopes like Hubble and James Webb are our windows to the universe, revealing distant galaxies and ancient starlight. They operate tirelessly, capturing data that expands our understanding of the cosmos. Without these robots, our knowledge of space would be a fraction of what it is today. They are the vanguard, mapping the unknown and paving the way for human missions. Their contributions are immeasurable, even if they don't get parades. Every image from Mars, every signal from a distant moon, is a victory for these mechanical explorers. They carry our curiosity into the great darkness. Our journey to the stars depends on their silent, relentless work. Space is unforgiving. Extreme temperatures, radiation, and flying debris make every moment risky for astronauts. Robots are more than tools. They're guardians, taking on the most dangerous tasks. Robotic arms and drones repair equipment and inspect for damage, sparing humans from hazardous spacewalks. Cameras and sensors find cracks or dents far more safely than a human could. Inside the station, robots monitor life support and manage supplies, freeing astronauts for complex research. Robotic assistants fetch tools, run diagnostics, and keep experiments running, even while the crew sleeps. Every task a robot handles is one less risk for an astronaut. This partnership lets us build bigger, stay longer, and venture farther. Robots don't replace astronauts, they empower them. Together they make bold exploration possible and keep our explorers safe. The Canadarm is an icon of space robotics and international cooperation. First launched in 1981, this giant robotic arm moved satellites and equipment with remarkable precision. Its success led to Canadarm2 on the International Space Station, a marvel with 7 joints and the ability to move itself around the station. Canadarm2 assembles modules, moves massive components, and serves as a mobile platform for astronauts during spacewalks. Astronauts can ride the arm to work sites, reducing risk and effort. Attached to Canadarm2 is Dextre, a 2-armed robot that handles delicate repairs and maintenance. Dextre can replace batteries, install cameras, and perform tasks that would otherwise require risky spacewalks. Together, Canadarm2 and Dextre form a complete robotic maintenance system. This evolution, from a simple arm to a mobile, multi-tool platform, shows how robots have become essential partners in orbit. They are not just tools, but trusted crew members. The story of Canadarm is the story of robotics becoming indispensable in space. Our ambitions now reach beyond Earth. We're building a permanent presence around the moon and dreaming of Mars. The Lunar Gateway, a small station orbiting the moon, will be built and maintained largely by robots. Advanced robotic arms will assemble modules, dock spacecraft, and keep the outpost running, even when no humans are aboard. Automation is key to making lunar exploration sustainable and safe. On Mars, robots will be our scouts and builders, preparing habitats and extracting resources before humans arrive. Imagine rovers 3D printing landing pads or mining water from Martian ice. Robots will build the first outposts, ensuring a safe base for future astronauts. Once humans land, robots will explore dangerous terrain, carry equipment, and maintain life support. Human-robot interdependence will be vital for survival and success on Mars. The dream of Mars rests on a foundation of advanced robotics. Our future on other worlds depends on these tireless mechanical partners. Robotics is the bridge to a multi-planetary future. The real power in space exploration comes from humans and robots working together. On the ISS, astronauts use robotic arms to perform tasks outside while staying safe inside. Robots provide strength and endurance, humans offer intuition and adaptability. Telescience lets scientists on Earth control experiments in space through robotic interfaces, multiplying the station's scientific output. On Mars, rovers like Perseverance navigate with a mix of human guidance and robotic autonomy. Humans set the goals. Robots handle the details, making exploration safer and more efficient. In the future, astronauts on Mars might explore with robotic companions, scouting, carrying tools, and alerting to danger. This is not a master-servant relationship, but a partnership of explorers. Human creativity and robotic precision combine to unravel the secrets of new worlds. This tandem approach is how we'll make our greatest discoveries. The future of exploration is a conversation between human and machine. Together, they will go farther than either could alone. This synergy is the key to unlocking the universe. The next era of orbital robotics will be defined by autonomy and artificial intelligence. Future robots will learn, adapt, and perform complex tasks with minimal human input. Self-assembling structures could build massive telescopes or habitats in orbit, piece by piece. Robotic servicing vehicles will refuel, repair, and upgrade satellites, reducing space junk and extending lifespans. Orbital factories may 3D print new satellites and tools using materials from Earth or asteroids. Swarm robotics, hundreds of small cooperative robots, will inspect, repair, and even remove debris with resilience and efficiency. These swarms will adapt to failures and continue their missions, making space operations more robust. The goal: a self-sustaining robotic ecosystem that builds and maintains our space infrastructure. Powered by AI, these robots will diagnose problems and devise creative solutions on their own. They'll free humans to focus on exploration and science. Intelligent robots will be the architects of our future in space. The new domain for life beyond Earth will be built by their hands. Space exploration's benefits reach far beyond the stars. They're woven into our daily lives. Technologies developed for space often become essential on Earth. Remote health monitoring, perfected for astronauts, now saves lives in hospitals. Robotic surgery systems trace their roots to space robotics like Canadarm2. Everyday items, memory foam, cordless tools, freeze-dried food, originated from solving space challenges. Satellite imagery helps farmers, tracks climate change, and aids disaster response. The overview effect, seeing Earth from space, has inspired global unity and environmental stewardship. Space technology helps us become better caretakers of our planet. The spin-offs from space missions ripple through society, driving innovation. By reaching for the stars, we improve life on Earth. The quest for space is a quest to better ourselves and our world. Humanity's story is one of exploration, and the cosmos is our final frontier. The partnership of human creativity and robotic resilience will unlock this future. Space exploration is a shared human endeavor, uniting nations and talents. The International Space Station proves what we can achieve together. As we reach for the Moon and Mars, cooperation will be more vital than ever. The robots we build are not replacements, but extensions of our curiosity and will. They will help us become a multi-planetary species, securing our future and opening new possibilities. Exploring space is exploring our origins and destiny. Our intelligence, curiosity, and robotic creations will write the next chapter. Together, we will take our place amongst the stars.